All right, I'm going to do one more, except I'm going to change this. I think the bisect's pretty easy. For the bisect, you just swing it through, and then you get two out here. Go look at the other link if you're having trouble with that. I'm going to change this to duplicate or copy because I just want to point out what I said before over here. I could create a triangle and then just duplicate it, and then like if I was trying to get angle E, I would have angle E here. So I could create some triangle. I could say MON, or I could actually create a point there and duplicate it. But the idea is ignore those points, okay? We're going to duplicate that, and essentially all we're doing is we're creating an equilateral, an isosceles triangle, and then duplicating that. It's one less measure. So if I just swing through here, this is actually kind of the arc that I'm going to use to help me measure. I've got an arc that big. That essentially establishes 2 points that are that are isosceles in distance. This thing could be anything, but these distances have to be duplicate now. So if I wanted to create that same angle, maybe down here, maybe pointing in a different direction, maybe I kind of want it pointing in this direction. Okay, so there's my n prime m side. Okay, I'm not going to try to figure out where m is. I'm just saying, well, that's the corresponding side. And then I'm just going to say, okay, how far apart is this unknown side? Because, okay, I've forgotten to transform measure. So we know two sides of this, quote, triangle or angle that we're doing have to be equal distance away. So this side and the side I haven't drawn in, again, are both going to be that distance away. So the question is, well, how big is that? So that unknown side of that isosceles triangle is this big. So I'm like, oh, okay, that unknown side is this big. Ignore the O there. It's just kind of in the way. So ignore that. So there's my other side. If I was going to label these, maybe to make this a little easier, let me go back. I'm going to create I'm going to say this was K and this was L. So this point right here is actually K prime, and this point right here is actually L prime. Forget the M and the N. Pretend they weren't there. Okay? And so now when I draw that in, those are duplicate because these two sides have to be the same. I created basically a little invisible isosceles triangle there. These two sides have to be the same because I used that same. And then I measured out how big was that invisible third side. Whatever that is the same side there. I can connect them. But that's the basic idea. And I like to point that out because I think people really understand this, and they don't realize that when you're duplicating an angle, you're kind of doing the same thing. You could do exactly the same thing, but if you do it the way that it's shown, instead of recreating a random triangle, you're actually recreating an isosceles triangle, and then you're just duplicating it down here. You're doing the first two sides in one fell swoop, and then you're measuring that unknown third side with an actual measure. Okay, that's plenty.